Some more PFD here. The denominator is factored into two linear factors. There's the first linear factor with a multiplicity of 2, and there is the second linear factor with a multiplicity of 1. So we're going to take the integrand here, and we are going to break it down into partial fractions, which are then easier to integrate. So we need to have a partial fraction for each power of each factor. So the first factor is x, and it's raised to the second power, so we need to have a partial fraction for each power of that. And then we have to have a partial fraction for x plus 3. We now multiply the entire equation by the left denominator. And when that distributes, we end up with our PFD equation that looks like this. So the distribution creates some cancellation. And we're left with that as our PFD equation. Now we've got some linear factors here, so let's go ahead and use the convenient value method. So we're going to plug in, say, x equals 0. That's one of the convenient values. On the left, you'll get negative 33. On the right, when we plug in 0, well, we're going to have a cancellation there and a cancellation there. Those are both going to go away if x is equal to 0. So we end up with 3b, which tells us b is negative 11. Well, let's plug in another convenient value, x equals negative 3. On the left, we'll end up with negative 36. On the right, when we plug in negative 3, that'll go away, that'll go away. Negative 3 plus 3 is 0. So the only one remaining is there at the end. And plugging in negative 3 is going to give 9c. And so c is going to be negative 4. All right, we have one more unknown to go. We don't have a true convenient value that's left, but we can pick a convenient-ish value, like 1 or negative 1 or whatever. Doesn't really matter. So let's just go ahead and pick 1. On the left, 1 minus 33 is negative 32. On the right, plugging in a 1 will give us 4 times a plus 4 times b plus c. We're going to take the b and plug it in there. We're going to take the c and plug it in there, and then solve for a. So we have negative 32 equals 4a plus 4b. Well, b is negative, so we're going to end up with negative 44. And then c is negative 4. So let's collect all our like terms here. So we're going to have negative 48 on the right. We add 48 to the left. So we will end up with an a value of 4. All right. That allows us to rewrite the integral as a divided by x. Well, our a is 4, so that's 4 over x. And then b over x squared, we found b to be negative 11. So I'm going to write that as negative 11 x to the negative 2. It'll be easier to use the power rule if we move it up top. And then minus 4 over x plus 3 dx. And then we're good to go. So this will integrate to 4 natural log absolute value of x. And then here we add 1 to the exponent, getting negative 1. We're going to divide by that negative 1, giving us positive 11. And then x to the negative 1 puts an x in the denominator. And then minus 4, natural log, absolute, x plus 3. And then our constant of integration. And there we go. We see that breaking that complicated denominator into partial fractions makes it a lot easier to integrate.